Good morning, students. Am I audible? Okay. So today we are going to solve few more numericals related to our uniform flow. Okay. So our next numerical is for triangular channel. Okay. So this is our next numerical. You can write it down the question. Okay. So what it's given, we need to find out normal depth. Find the normal depth of a triangular channel. Okay. This time the channel is triangular, having longitudinal slope. See, longitudinal slope is nothing but your bed slope. Okay, longitudinal slope is nothing but your bed slope. Bed slope. Okay, or you can also say it is a SB. Okay, bed slope. Okay, side slope is given 1:1. Okay, so this is what 1:, Z. In general, we write Z. Okay, as it is 1:1. So you always remember when your side slope is 1:1, you can directly consider Z equal to 1. Okay. Okay. So whenever you remember if your side slope is 1:1, you can directly consider Z is equal to 1. Okay. And then discharge is given. Discharge is given 1 meter cube per second. 1 meter cube per second. Discharge. Okay. And roughness coefficient is given 0.014. Roughness coefficient is given 0.014. So we need to find out the normal depth, or you can say y. Okay. We need to find out the y value. So this is a triangular channel. Side slope is given 1:1. Okay. We don't have any bottom width in a triangular channel. So it's also not given. Okay. Our bottom width of the channel is 0. Okay. And what we need to find out is y value. So if you see here, discharge is given area into velocity. Okay. Area into velocity. So discharge is already given area. You can find out here. Okay. And velocity also you need to find out using Manning's equation. Okay, so you try to solve these questions. Okay, try to solve. You need to find out yn. Okay, that is nothing but your normal depth of the channel. Page slope is given. Manning's n is also given. Okay, and area of a triangle is nothing but your half into base into altitude. Okay, h. To talk about base, okay. So here in this triangle, in this triangle, Base is this side, okay? This is our base, okay? And this is our altitude, okay? So in place of base, see, we have already discussed how and why it is zy from here to here, okay? This is zy, and as the side slope is same, so this will be same zy. So base you can write twice multiplied by zy, okay? Zy, and then height. Height is nothing but your depth of flow, okay? Or you can write, in this case you can write yn, okay? That is your normal depth. So this 2 and 2 cancel out. Z is equal to 1. Okay, we have already discussed about it. Z is equal to 1. So we substitute Z is equal to 1 and is equal to y square. Okay. Okay. So area, in place of area we can write y square in this numerical. Okay. So you can write y square. Okay. Since Z is equal to 1, we can write A equal to y square. Okay. Then to find out velocity, as Manning's roughness coefficient is given, so we have to use Manning's equation, that is 1 by n r to the power 2 by 3 sb to the power half. Okay. So in this equation, n is given, base slope is also given, that is 4 into 10 to the power minus 4. Okay. What is left out? We need to find out r. To find out r, we have area by weighted perimeter. Okay. Okay. Then you find out the weighted perimeter, okay, and substitute here, find out r, and you find out velocity. Okay. Once you have calculated velocity, you use this equation, discharge equal to area into velocity. Okay. Discharge is given, that is 1. In area, in place of area we can write y square. Okay. We can write y square from this equation, then multiplied by velocity. Whatever the velocity you are going to get, you substitute here. Okay. Okay. So you can directly find out the y value. Okay. So try to calculate and see your value, you are getting 1.13 or not. Okay. Try to solve and see you are getting the same value or not. If you have any doubts, you can ask me. You're getting the same value, 1.13. Okay. So if you're getting the same value, then we are going to move on to the next numerical. Okay. Okay. So next numerical. So what is given here? Find the discharge. Okay. We need to find out the discharge. That is Q. Okay. Q we need to calculate. Okay. And then the channel is trapezoidal channel. It's given. The channel is trapezoidal channel with a bed width, that is your bottom width of the channel is 10 meter given. Okay. So what is given? Discharge we need to calculate. Channel section is trapezoidal. Bottom width of the channel is 10 meter. Side slope is 1 is to 1. Okay. When it gives 1 is to 1, then Z value we can directly consider is equal to 1. Okay. It's very easy to calculate. Okay. When you have a side slope of 1 is to 1, you need not to find out the Z value. You can directly consider it's equal to 1. Okay. Depth of flow is given 2 meter. Okay. Depth of flow is given 2 meter. And then what else is given? Okay. Slope is given 10 to the power minus 4. That is your bed slope. Bed slope is given 10 to the power minus 4. Manning's roughness coefficient is given. Okay. N is equal to 0.02. Okay. So in this question we have two parts. One, using this Manning's equation, we have to find out the discharge of a trapezoidal channel whose bottom width is 10 meter, side slope is 1 is to 1, depth of flow is 2 meter, and the longitudinal slope, or you can say bed slope, is 10 to the power minus 4. Okay. The second part is we have to find the Say's coefficient. Okay, for the same channel. Okay. I think we have already discussed the relationship between Say's constant and Manning's equation. I have given one equation to you. We are going to use that same equation to find out the Say's constant. Okay. Okay. So you try to solve the first part. Okay. First part is nothing but we need to find out the discharge. Okay. First part is nothing but we need to find out the discharge. Discharge is nothing but area into velocity. So first we need to find out the area. Okay. First you find out the area. Okay. So here the side slope is given 1 is to 1. So we can directly consider Z is equal to 1. Okay. So this is your ZY and this is also ZY. To find out the area, we need both bottom width and top width of the channel. So sum of the parallel sides divided by 2 multiplied by the vertical distance. Okay. So one parallel side is 10 meter. Second one is, this is 10 meter. The middle portion. Okay. If you see, this is our rectangular. Okay. This portion is our rectangular. That is why we have considered this is as 10 meter. Okay. Side slope is, y value is given 2 meter, z is equal to 1. So this is 2 meter and this is 2 meter. 2 plus 2, 4 meter plus 10. Okay. 2 plus 2, 4 meter plus 10 meter, it's 14. Okay. This is 2 meter, this is 2 meter, and this is 10. Okay. So it's all together, you will get 14. So 14 plus 10 divided by 2 multiplied by the vertical distance. This is nothing but again your 2 meter. Okay. So this 2 and this 2 will cancel out. Area you are going to get is 24 meter square. Okay. And then similarly, you find out the weighted perimeter. Okay. Similarly, you find out the weighted perimeter of the channel. Weighted perimeter means you have to consider this side, then bottom of the channel, and then side of the channel. Okay, these are the sides you are going to consider for weighted perimeter. Okay, so again you have to use here Pythagoras theorem to find out this side, find out this side, and as these two triangle is same, so you can directly multiply it by 2. Okay, so that's what we have done here. Okay, b, that is your bottom of the channel, plus twice root over using this Pythagoras theorem. Okay, this is also 2 and this is also 2, as z is equal to 1 in our case. Okay, so 2 square plus 2 square, ultimately you are going to get it's 15.66 meter. So area you have already calculated, weighted perimeter you have calculated. Next, we need to find out velocity, because our intention is to find out discharge. Okay, that is area multiplied by velocity. Area we have calculated. Now we need to find out velocity. Then we multiply both. We will get discharge. Okay? And why we have calculated weighted perimeter? Because the velocity equation 1 by n r to the power 2 by 3 s b to the power half. So in that particular equation, to find out velocity, we need to find out the r value. As base slope is given, n value is given, but r we need to calculate. And r is nothing but your area by weighted perimeter. Okay, so that is why we have calculated weighted perimeter. Okay, so you find out velocity and then you calculate discharge. Okay, see you are getting the same value or not. It's approximately 16 meter cube per second discharge. Okay, velocity is 0.66 meter per second. Try to calculate and see you are getting the same value or not.
Main paling ganda. Wow. Iya. Tinggal kita.
Okay, you got 15.95. So yeah, that is approximately your 16. Okay, that also you can consider as 16 meter cube per second.
Ayo. Enggak. Enggak.
Okay, you got 15.84. Okay, okay. Then we move on to the next part of our problem. Okay, okay. Now we need to find out the Sages constant. Okay, so we all know that Sages equation is nothing but V equal to Sages constant root over R S. Okay, this is your nothing but your base slope. Okay, so from here we can find out C, that is Vy root over R bed slope. Okay, so you can directly find out the C value. Okay, velocity we have already calculated. I think it's 0.66. Okay, then R value we have already calculated. That is nothing but your A by P multiplied by base slope. That is your 10 to the power minus 4. Okay, you substitute these values and you find out the says is constant, that is C. Okay, and see you are getting 53.31 or not. Okay, as C is your says is constant, we don't have any dimension. Okay, or we don't have any unit. It will be 53.31. Over, you're getting the same value 53. Okay, okay. Then we move on to the next numerical. Okay, okay. You kindly write down the numericals. Okay, write down the questions. This is the question. Okay, so that the normal depth in a triangular channel of side slope, okay, is given by, you write this expression. In this numerical, we have to show that yn for a triangular channel is this equation. Okay, we have to prove. It's kind of derivation only. Okay, we have to derive for yn of a triangular channel when side slope is z horizontal is to 1 vertical. Okay, over, you just write it down the question. Okay, and if it is done, then let me know. So that is a yn is equal to 1.189 discharge multiplied by n. N is nothing but your roughness coefficient. divided by root over base slope whole to the power 3 by 8 multiplied by z square plus 1 divided by z to the power 5 whole to the power 1 by 8. Okay, we have to prove this for a triangular channel. Okay, okay. See, there are various way you can derive that one. Okay, even I have done with two process. Okay, so I think this one is simpler. That is why we are discussing this. Okay, see here I have already written it's an alternative method. Okay, you can do by using that method also. That is a little bit lengthy, and as our duration for examination is reduced, so that is why I want to go with this alternative method. Okay, so this is an alternative method, or you can take as a primary method. Okay, so we are using this method to find out that expression. Okay, so here what is given, it's a triangular channel is given. Okay, and then side slope is given 1 is to z. Okay, z horizontal is to 1 vertical, that is 1 is to z. Okay, then we have considered this whole angle as theta. Okay, you kindly draw this diagram. Okay, so this whole angle we have considered theta. So definitely this line will divide the angle into two equal parts. One part will be theta by 2. Okay, okay, and another part will be theta by 2. Okay, so whole angle we have taken theta, and this vertical line or vertical axis, it will divide the whole angle into two equal parts. Okay, one part will be theta by 2. Okay, okay. So definitely this will be your zy. Okay, this will be your zy, and again this is also zy. Okay, these things we have already discussed. Okay, and we have marked this point as a and this point as b, and the bottom of the channel is c. Okay, a, b, and c. Okay, and we all know this is a right angle triangle. Okay, the depth of flow we have considered y. Depth of flow we have considered y. Okay, then we are going to consider this triangle a, b, and c. Okay, a, b, and c. So it's a right angle triangle. So you can see here a, b, and c. Okay, so ab is nothing but your zy or yz. Okay, same thing. So that's why ab is nothing but our zy. Then AC is nothing but our depth of flow. Okay, this is A and this is C. So this is nothing but your depth of flow. That is why we have considered Y. Okay, and then angle C for this particular triangle is theta by 2. As we have already discussed, the whole angle we have taken theta, and this vertical axis will divide the whole angle into two equal parts. Okay, so each part will be theta by 2. Okay. Now we have this side AC, we have AB. We are going to use Pythagoras theorem to find out this side BC. Okay? That is nothing but root over square of square and then summation of the two sides. Okay, so that is why zy whole square plus y square root over. Okay, so y square and y square we can bring it out. What will be left out is root over z square plus 1. Okay, y square and here also y square we can bring it out. Okay, so y root over z square plus 1. Okay, that is nothing but your BC. Okay, then we consider tan theta by 2, that is tan theta. Okay, but here that theta is nothing but our tan theta by 2. So tan theta is, so tan theta is perpendicular by base. Okay, so here you can say tan theta is nothing but your perpendicular by base. This is your 90 degree, so you can say zy divided by y. So this y will be cancelled out. Ultimately you can write tan theta by 2 is equal to z. Okay, as theta in our case is theta by 2. Okay, sin theta, cos theta, tan theta, we have already studied those things. So tan theta is perpendicular by base. So perpendicular in this triangle is zy and base is nothing but your y. So this y will be cancelled out and what will be the left out is z. So you can directly write tan theta by 2 is equal to z. Okay. And similarly, if we consider sec theta by 2 is bc by y. Okay, then bc value you substitute from here. It is y root over z square plus 1 divided by y. So this y will be cancelled out and ultimate result you are going to get is z square plus 1. Okay, these are the two components. Okay, one tan theta by 2 and sec theta by 2. Okay, okay. Now we will come to the whole triangle. Okay, and we find out the area. Area is nothing but half into base into altitude. So half base will be this. It is twice zy multiplied by y. Okay, so this two will be cancelled out. Is left out is zy square. Okay, so this is our area equation for our present case. Okay, yeah. Then we go for weighted perimeter. Okay, weighted perimeter is nothing but both the side of the triangle. Okay, BC by CD. Okay, D is nothing but this point. Okay, this point is D. D is nothing but this point. This is your D. Okay, so this is A, this is your B, this is your C, and this is your D. Okay, triangle ABC we have already done. Okay, so now we are coming here for weighted perimeter. Okay, so weighted perimeter is nothing but our CD plus BC. Okay, so BC is nothing but your, we have already calculated here, y root over z square plus 1. Okay, so that is why BC is nothing but your, Okay. So BC is nothing but we have already calculated, that is y root over z square plus 1. Okay. And both the sides are same. Both the sides is same. Both the sides will be same. So we will multiply it by 2. Okay. So we are going to multiply it by 2. So what is written? BC we have calculated. BC is nothing but y root over z square plus 1. Okay. Z square plus 1. Okay. And sec theta by 2 is nothing but your BC divided by y. Okay. So in place of BC, you can write BC y theta by 2. Okay. That's what is written. Okay. And as these two are same, we have multiplied by twice. Okay. So it's up to you. You can directly write BC is equal to y root over z square plus 1 and multiplied by 2. Ultimately, you are getting the same result. Okay. Next, we will go to our discharge equation. Okay. So this is Q. Area is nothing but zy square. Okay. Okay. Area is nothing but zy square. Here you see area is nothing but our zy square, and in place of z we can write tan theta by 2. Okay, we have already calculated. Okay, so area we can write y square tan theta by 2. Okay, actually the expression for area is zy square, but in place of z we can also write tan theta by 2. Okay, so that is why in tan in z we have replaced tan theta by 2. Okay, then we have used Manning's equation. So 1 by n r to the power 2 by 3 s to the power half. Okay. So here y square tan theta by 2 root over slope, we bring it out here in the left hand side. Okay. Here what will be left out, that is y square tan theta by 2 multiplied by, this is nothing but your r. Okay. R is your area by perimeter. Okay. Area by weighted perimeter. Okay. So the n we bring it out here, so it will be multiplied, and if you bring the slope, you bring this slope and this n value in the left hand side, it will be multiplied and the slope will be divided. Okay. So s to the power half or root s is same, and what will be left out is y square tan theta multiplied by, this is r. R is nothing but area by weighted perimeter. Okay. Area by weighted perimeter. So perimeter we have already derived, that is twice y sec theta by 2, and area we all know. Okay. It's zy square. In place of z we have substitute tan theta by 2. Okay. Then you simplify. Okay. Now we need to only simplify. Left hand side will be okay. This is also remain same, and then you solve here. Y square by twice y. Okay. Y square by twice y. So y will be cancel out. So y divided by twice. Okay. Y divided by 2. Other terms will be same. Okay. Again here this is same. Then we have 2 here, and we have power 2 by 3. Okay. So if you bring on the left hand side, It is 1 by 2, so it will be multiplied here. Here it is divide. If you bring it in the left hand side, it will be multiplied. And we have this power. So that is why 2 to the power 2 by 3. Okay. And then this will be your left out y square tan theta by 2. That is your area multiplied by, then this is to the power 2 by 3. Okay. So y to the power 2 by 3 tan theta by 2 to the power 3 by 3 divided by sec theta by 2 to the power 2 by 3. Okay. Then you come to the next line. So this will be remain same. Okay. Left hand side and right hand side y square. So you have y square and y to the power 2 by 3. So you can write y 2 plus 2 plus 2 by 3. Okay. Then multiplied by tan theta by 2, 2 by 3. So you can write tan theta by 2 to the power 1 plus 2 by 3. Okay. So that is why 3 to the 6 plus 2, 8, y to the power 8 by 3. Okay. Tan theta by 2. So you have 3 on the 3, 4, 5. Okay. So 5 by 3. Tan theta by to the power 5 by 3. And other terms will remain same. Okay. So again we are going to bring this side. This sec theta by 2 we have bring in the left hand side. So it is really multiplied. Okay. And this also you bring it in the left hand side. So it will be divide. Okay. Is equal to y to the power 8 by 3. It will remain same. Okay. Okay. Next we are going to cube both right hand and left hand side. Okay. We are going to take whole cube in both left hand side and right hand side. Okay. So that is why we are taking whole cube both left hand side and right hand side. Okay. Other terms will be remain same. Okay. Then 2 to the power 2 by 3 whole cube we will take. It will give you 2 to the power square. Okay. Here it is cube multiplied by 2 by 3. See 2 by 3 and whole cube you will get square. Okay. 5 by 3 then again you take whole cube. It will be your 5. Then y to the power 8. This is 8. Y to the power 8. As y to the power 8 by 3 whole cube, it will give you y to the power 8. Okay. So again, it will remain same. This is also remain same. And then here, tan theta by 2, we have substitute z. Okay. And sec theta by 2 also, whatever we have calculated, we have substitute here. Okay. And this will be remain same. So you further solve, you will get this expression. Okay. So I can understand it is very difficult to follow as we are discussing online. Okay. And the time is also about to end. Okay. So what I suggest you try to solve or derive this equation, or sorry, solve this numerical at home. And if you find any difficulties, we can discuss in the next class. Okay. So it's better if you try at home, and then I'm sure you are going to find some difficulties. Okay. So it doesn't matter in what approach you are going to consider. Okay. It may be different from what I have done. Okay. But at the end, we have to get this expression. Okay. At the end, we have to get this expression. Okay. So today we are going to end our class here. And if you find any